KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, now we are going to discuss some natural phenomena due to sunlight. Afterwards, we are going to discuss completely about one natural phenomena, that is rainbow. Okay ma? Right. So now we are going to discuss some natural phenomena due to sunlight. Okay, see here. So it is the topic of application to daily life. So in our daily life, we used to observe many natural phenomena. For example, blue color of the sky. Similarly, white clouds. Next, sunrise and sunset. Rainbow. Brilliant colors of some perils. That is what diamond shining of diamond. Okay, and then wings of birds. Wings of birds, right? So whatever the list just now I told you, like blue color of the sky and white clouds, sunrise and sunset, shining of a diamond and wings of birds, etc. So these are the examples of natural phenomena in our nature. Okay, right. So now we are going to discuss some other information, some more information about natural phenomena. See here, the interplay of light with rings around us gives rise to several beautiful phenomena. The interplay of light rays with rings around us gives rise to several beautiful phenomena. Okay, right. The spectacles of colors that we see around us, the spectacles of colors that we see around us all the time is possible due to sunlight. The spectacles of colors that we see around us all the time is possible due to sunlight. Next, color is associated with the frequency or wavelength of light in the given medium, right? Okay, so these 2 points he is talking generally. What are the things which happens because of sunlight, that he told me, but from here onwards you concentrate. So this is the important point. Color is associated with the frequency or wavelength of light in the given medium, right? So medium means is a substance which allows light energy to pass through it. So color physics, you know the wonderful colors in our surroundings, including primary colors. Okay, so that color is associated with a frequency or wavelength of light in the given medium. Next, in visible spectrum, red light and violet. So in visible spectrum, the wavelength of red light is 700 nanometers. So nano means 10 to the power of -9. Violet color, violet is 400 nanometers. right? So this is the wavelength of red light and it is the wavelength of violet which is present in the visible spectrum, right? Visible spectrum means it is VIBGYOR, no? So violet, indigo, blue, green, yellow, right? Orange, red. There are 7 colors in our visible spectrum. So first one is violet from one side, the last one is red. Okay, so here they have given wavelength of light, red light in the bracket, and wavelength of violet light in the bracket. Now next point, dispersion takes place because the refractive index of medium is different for different frequencies of light. Dispersion takes place because the refractive index of medium is different for different frequencies of light. So note down this point. Here he is saying the relation between refractive index and frequency, surface level. So simple as such, he is saying refractive index of medium depends upon the frequency. Next, for example, the bending of red component of white light, you know very well, white light is a mixture of 7 colors. It is not a monochromatic. White light is not monochromatic. It is polychromatic. So it consists of 7 colors, right? Okay. So the bending of red component of white light is least while it is most for the violet, right? So the bending of red component, see, the red component is bending very less, but violet bends more. So here red and violet, so the wavelength is different. Wavelength is different. Equivalently, red light travels faster than violet light in a glass prism. Red light travels faster than violet light in a glass prism. So in this paragraph, he is talking about the relation between refractive index and frequency. So he told that there is relation. There is relation. Next, he is saying that red light bends least and violet light bends more, even though both red and violet are the components of white light. At the same time, red light travels faster than violet light in a glass prism. In a glass prism. Okay, right. Next, here you can see the color and wavelength, and it is for crown glass and flint glass. So when these colors are traveling through crown glass and flint glass, see here. So it is for violet, these are the values, and for blue, these are the values, right? Similarly, yellow, these are the values, and red. So here he mentioned that refractive index of medium is different for different frequencies of light. Okay, so by seeing this table, we can understand the wavelength is differ for every, that is what violet, it has its own wavelength, blue, it has its own wavelength, similarly yellow and red. So if you see this with respect to type of glass, crown glass and flint glass, the values also different based on the color, based on the frequency, okay, or wavelength, right. Now you see that thick lenses could be assumed as made of many prisms. Thick lenses could be assumed as made of many prisms. Therefore, thick lenses show chromatic aberration due to the dispersion of light. What is meant by dispersion of light? When a white light is allowed to pass through any dispersive medium, it splits into its component colors from violet to red. So the phenomenon in which a white light is going to split into its component colors is simply called as dispersion. Okay, but all the medium cannot disperse the light. Okay, for example, glass is a dispersive medium. Glass is a dispersive medium. Whereas if you see the vacuum, in vacuum white light is not going to disperse. White light is same like white light only. But if you allow white light to pass through the glass, then you can experience the rest of the 7 colors. Okay, those are Vibja. See here, I told you what is meant by dispersion. Now again going back to back to our discussion. Thick lenses show, see, thick lenses could be assumed as made of many prisms. Therefore, thick lenses show chromatic aberration due to dispersion of light. So what is dispersion? Just now I told. What is chromatic aberration? See here, when white light passes through thick lenses, red and blue colors focus at different points. When white light passes through thick lenses, red and blue colors focus at different points. Red and blue colors focus at different points. Okay, when white light passes through thick lenses, red and blue colors focus at different points. This phenomena is known as chromatic aberration. Chromo means color, right? So chromatic aberration. Next, the same points what I discussed just now before 1 minute, he repeated again. You see this. In vacuum, speed of light is independent of wavelength. In vacuum, speed of light is independent of wavelength. Is an important point you have to note down. Next, vacuum is an example of non-dispersive medium in which all the colors of light travel with the same speed. This is also next important point. Afterwards, sunlight reaches us in the form of white light and not as its components. On the other hand, glass is a dispersive medium. Glass is a dispersive medium. Okay. So in our discussion, some natural phenomena due to sunlight. What are the natural phenomena? We discussed. So nearly I told 5 to 6 natural phenomena. Afterwards, what's happening? What is the relation between refractive index and frequency, right? And what happens to the amount of bending in case of colors present in the visible spectrum from violet to red? Afterwards, what about the speed of light? What about the speed of different components of white light in case of glass prism? Afterwards, what is meant by dispersion? And then, what is meant by chromatic aberration? Afterwards, what is the difference between vacuum and glass regarding the dispersion and regarding the speed of light also? In case of vacuum, speed of light is independent of wavelengths. Okay, vacuum is non-dispersive medium in which all colors of light travel with the same speed, but it will not happen in case of glass. In case of glass, components are going to travel with a different speed so that you can experience dispersion, so you can observe all the colors components of a white light. Okay, right. So this is about some natural phenomena due to sunlight. Now we are going to discuss another, this is also one of the natural phenomena, but we are going to discuss completely. We are going to discuss completely how it forms, how this natural phenomena forms in our nature, that is rainbow. So we all, including me, right, we experienced rainbow so many times, right? So generally if you observe, so when rain falls in the presence of sunlight, when rain falls, you can experience this rainbow many times. Okay, right. Now we are going to discuss how the rainbow will be formed, how we are going to get different colors of rainbow. Okay, when rain falls in the presence of sunlight. Okay, that we are going to discuss now. See this. It is an example of the dispersion of sunlight by the water drops in the atmosphere. So what is that? Rainbow. rainbow is an example of the dispersion of sunlight by the water drops in the atmosphere. In the atmosphere. Okay. Next, this is okay in the atmosphere. This is a phenomena. This is a phenomena. This is a phenomena due to the combined effect of dispersion, refraction, and reflection of sunlight. This is a phenomena due to combined effect of dispersion, refraction, and reflection of sunlight by spherical water droplets of rain. So, rainbow is an example of the dispersion of sunlight by the water drops in the atmosphere. Next, this rainbow is the combined effect. This natural phenomena, rainbow is the combined effect of dispersion, refraction, and reflection of sunlight by spherical water droplets of rain. By spherical water droplets of rain. Okay, right. So, what are the conditions? What are the conditions to experience rainbow in our atmosphere? Right. The first condition is sun should be shining in one part of the sky. Sun should be shining in one part of the sky while it is raining in the opposite part of the sky. So, the first condition is sun should be shining in one part of the sky while it is raining in the opposite part of the sky. In the opposite part of the sky. Okay. Next, second one is observer's back is towards the sun. Imagine yourself, observer's back is towards the sun. Okay, right. Now, with the help of these many pictures, we are going to discuss how the rainbow is going to form. So, this is the picture which shows rainbow, right? And this is the picture which shows a primary rainbow. This is the picture which shows a secondary rainbow, right? So, if you see this one here, this is the position of the observer, right? So, it is a raindrop. It is the raindrop. It is the sunlight, right? It is the sunlight. Okay. So, sunlight is coming from here. First, the sunlight is going to enter from air to water, so that it is going to refract. Then again, here, when the angle of incidence is greater than critical angle, what happens? The light will be totally reflected into the same medium. Totally reflected into the same medium. At the same time, here again it is going to refract. When it is entering from water to the air, again it is going to refract. So, this is the situation happened when a sunlight is going to pass through the water droplet, otherwise a rain drop. Okay, right. And if you observe carefully, sunlight first refracted at this point, okay, which causes the different wavelengths of white light to separate. Okay, longer wavelength, that is red, bent the least, as I told just before 1 minute, while the shorter wavelength violet bent the most. So, bending of red is less and bending of violet is more. Okay. So, the component rays strikes the water droplets, component rays strike the inner surface of the water. Component rays strikes the inner surface of the water drop and get internally reflected if the angle between the refracted ray and normal to the drop, if the angle between refracted ray and normal to the drop surface is greater than the critical angle, here it should be 48 degrees in this case, here it is 48 degrees. Okay. So, that afterwards you can say the reflected light is refracted again, reflected light is refracted again when it comes out of the drop here. Okay. So it is found that violet light emerges at an angle of 40 degrees. Violet light emerges at an angle of 40 degrees, and red light emerges at an angle of 40 degrees when compared to the incident light. So this is the incident sunlight. When compared to the incident sunlight, violet emerges at an angle of 40 degrees and red light emerges at an angle of 42 degrees. Okay. So for other colors, whatever it may be, between the violet and red, between the violet and red, so the angles will be in between 40 degrees to 42 degrees. This is the situation takes place in case of rainbow. In case of rainbow. Okay. Right. Next, it is here we are taking two water drops, right? Because when rain falls, when we are going to observe the sunlight among the water drops or raindrops, okay, so there are millions of raindrops, okay, thousands and millions of raindrops, not a single raindrop. This is the situation because of single raindrop, but if you take two raindrops, what happens? So the rainbow will be formed. So the colors what we are going to observe in the rainbow is because of single drop, is because of two drops, right? But we are experiencing the rainbow because of thousands of drops. Okay, right. So here we are going to discuss how the primary rainbow will be formed. You can see in our atmosphere primary rainbow and secondary rainbow also. Primary rainbow and secondary rainbow also. Okay, see this. Here, if you observe carefully, the red light is from drop 1 and the violet is from drop 2. Okay, reach observer's eye. So here is the observer, here is the eye. Okay, the violet from drop 1 and red light from drop 2 directed at level above or below the observer. Above or, see the red light ma, above or below the observer, right? So the observer sees a rainbow with red color on the top and violet on the bottom. Red color on the top, violet on the bottom. Okay, right. Afterwards, if you observe carefully, this primary rainbow is a result of three-step process. You can ask what are the three steps, right? So the first one is refraction, another one is reflection, and another one is refraction, right? Say this: refraction, reflection, and refraction. Okay, so this is the formation of primary rainbow includes or consists of three steps: refraction, reflection, and refraction. Okay, right. Next, now we are going to see how a secondary rainbow is going to form. How a secondary rainbow is going to form. See this here. This is the picture or figure which gives information about secondary rainbow, right? In our sky, in our atmosphere, sometimes you can see both primary rainbow and secondary rainbow also. Primary rainbow, okay, we discussed how it forms, but how the secondary rainbow will form in our atmosphere. Okay, right. See this. When light ray undergoes two internal reflections. See here, ma. It is one and it is another. So the light ray is going here and here and here. So two internal reflections inside a raindrop. This is the output. I mean, this is the final light ray. Here also it is the final light ray because of two raindrops. Okay, right. So here, this is the four-step process. Right? So these four steps are like first it is going to refract, then it is going to reflect, again it is going to reflect, Now it is going to, here it is going to refract, right? So refraction, reflection, reflection and then refraction. It is a 4-step process. Unlike primary rainbow, it is a 3-step process: refraction, reflection, refraction. But secondary rainbow is 4-step process: refraction, reflection, reflection and refraction. Okay. But here intensity of light is reduced in case of second reflection. That is the reason. So here intensity reduced in case of second reflection. That is the reason primary when compared to the primary rainbow, the secondary rainbow is somewhat less intense. So you can say that fainter than primary rainbow. Okay. Afterwards, the order of the colors is also reversed in case of secondary rainbow when compared to the primary rainbow. Okay. So this is all about rainbow and how it is formed. So here you can see what is a rainbow. Okay. And the rainbow is because of what natural phenomena in our atmosphere. Afterwards, the conditions to obtain rainbow in our atmosphere, in our sky. Afterwards, generally because of single water drop, how can we experience the rainbow? And because of 2 water drops, how the primary rainbow will be formed. And it is a 3-step process: refraction, reflection and refraction. And how secondary rainbow will be formed. It is a 4-step process: refraction, reflection, reflection and refraction. Because of reflecting 2 times, the intensity will be decreased, so that the secondary rainbow will be less intense when compared to the primary rainbow, right? So this is the information about rainbow. So in this class, we discussed about some natural phenomena due to sunlight. So rainbow is not only the natural phenomena, right? So we have blue color of the sky, white clouds, sunrise and sunset, shining of diamond and wings of bird. Okay. So these are all natural phenomenon what we are experiencing in our day-to-day life. Okay. So what is the relation between different quantities in case of natural phenomena? So what is the refractive index and relation between refractive index and frequency? Similarly, refractive index and what is that color, and with medium also, okay. So afterwards we discussed what is dispersion and what is chromatic aberration. Afterwards we went to discuss rainbow and formation of rainbow. There itself, formation of primary rainbow and formation of secondary rainbow. Okay ma? Right. We will continue in the next class.